Hi everyone, Master TJ here. Let's get started on another assumed knowledge problem. Yes, that is what I like to call word problems. I like to be very honest with students about why they are so challenging. They are assumed knowledge problems. When a problem creator is writing a problem, they are creating the problem with the expectation that a student at a particular concept level has mastered the prerequisite for that concept, and it is really the time to show and tell whether you have mastered the concept and the prerequisites for the concept. So it is the time where you do have to really show and prove. There's no more, okay, these are the steps I take, yay me. You actually have to show what you know. In this particular problem, a farmer has a rectangular garden plot surrounded by 200 feet of fence. Find the length and width of the garden if its area is 2,400 square feet. Well, I'm looking at this and there are some things that are assumed. I know what a rectangle is. I know what surrounded means as opposed to inside, surrounded, the outside, the perimeter. That surrounded brings the image of perimeter to my brain. Find the length and width of the garden if its area is 2,400 square feet. What is area of a garden, of a rectangle? These are these are the things that the problem creator had in mind. These are the expectations that the problem creator had in mind when writing this problem. We are going to solve this problem in the end. Our final answer is going to come from solving a quadratic. But before we even get to the quadratic, there are some things we had to know before we even got there. So let me draw my rectangle. My rectangles are always a little slipshod here, but I'm an artist. I'm a mathematician, not an artist. I really should be able to draw a decent rectangle by now. I've been doing this for years, but all right, there we go. And it's some width and it's some length. And we know that around this, whatever these lengths and widths are, they equal 200. So at this point, I have two L's plus the two W's, and they equal 200. I also know that area of a rectangle is length times width. And in this case, area is 2,400. These are just the things that I know from what I've been given. At this point, I haven't calculated anything. I've just read the problem, pulled out the information, and now I'm looking at it thinking, okay, well, what do I do? At this point, it tells me to find the length and width of the garden. Well, that means I'm looking for L and W. How can I find L and W from this? So it looks like a system of equations, maybe. I don't know. Maybe I can solve for one and input it into the other. Let's see how that works. This one looks best. So I'm going to divide both sides by 2 to make things smaller. So that's L plus W equals 100. And I do prefer solving for L. So L equals 100 minus W. Well, I can certainly replace this L with that L rather. So 2,400 equals 100 minus W. I'm going to keep that in the parenthesis because this entire expression is for L times W. Well, a little algebra here. 2,400 equals 100 W minus W squared. Well, that certainly looks more like a quadratic. So I'm going to put this quadratic in standard form, and my goal is to get rid of this negative in front of my square term. It makes it more difficult to factor, at least to me. So I'm going to move everything on this side over to the left side. How do I do that? I'm going to add W squared to both sides, and I'm going to subtract 100W from both sides. Okay. And now, because my handwriting is so funny looking, I'm going to just rewrite this nice and neat so everyone can see where we are. 0. This is factorable. Or you can put it in your graphing calculator and look for the zeros. In this case, because I see this 24 and both of these are 100s, I'm thinking, I don't know. 24. What are the things, excuse me, both of these have zeros on the end. I said both of these are 100s. Let me say that a different way. Because both of these have zeros on the end, I'm really focusing on that 24 and factors that may bring me up to 24. Well, let's also consider the signs. I know that I have a positive here. So that means both of these are either positive or both are either negative. Since I have a negative here, that tells me both are negative. I know this. So I'm going down and I'm thinking, well, things that equal 24. I know 12 times 2 equals 24. I know 6 times 4 equals 20. Oh, I'm going to stop there. 6 times 4. Because 6 plus 4 equals 10. Oh, well, that might work. But I have zeros on the end. And again, this is my mental math and number sense, thinking of ways to break up the number 2400 to where when I add these digits together, excuse me, when I add the numbers together, they're going to give me 100. So 60 times 40 certainly equals 2400, and 60 plus 40 equals 100. So, well, that certainly is awesome. Okay, so here we are. We have now that W equals 60, W equals 40. The beauty of this problem is that your final dimensions are actually 60 and 40. I can choose either one of these and plug them back into my equation for L, and I will have a satisfactory answer. So let's say I want W to equal 60. I say L equals 100 minus 60. L equals 40. And width equals 60. And we are done.